In this section, we're introducing our password manager, which is designed to securely store and retrieve your passwords using Python and Fernet Encryption. The core principle here is to keep your sensitive information safe from unauthorized access. By utilizing strong encryption, we ensure that your passwords remain confidential, turning them into unreadable strings that can only be deciphered with the right key. This approach not only protects your credentials, but also reinforces best practices in digital security, making it much harder for potential attackers to exploit weak passwords or gain access to your accounts. Overall, this tool is a practical solution for enhancing your online safety and maintaining the privacy of your personal information. Before we can start saving passwords securely, we need an encryption key. This key will play a crucial role in protecting the sensitive data we'll be managing. Think of it as the master key that locks and unlocks all of our stored passwords. If someone gets access to our passwords without this key, they could easily compromise our accounts, so we want to handle it with care. To begin, we'll generate a secure encryption key using the Fernet symmetric encryption method, which is part of the cryptography library. Fernet provides a way to encrypt our data so that it remains unreadable to anyone who doesn't have the key, ensuring that even if someone gains access to our password database, they won't be able to decipher the information. Once we generate the key, we must also think about where to store it. Storing the key directly alongside the passwords would defeat the purpose of encryption. If an attacker gains access to both, they could easily retrieve the stored passwords. Instead, it's advisable to save the key in a secure location on our machine. A common approach is to save it in an environment variable or a secure configuration file that is not included in version control systems like Git. Next, we'll actually generate the key and then write a snippet of code to save it securely. This process ensures that our password manager will be fortified against unauthorized access, offering a robust defense for our sensitive data as we build out the functionality of the app. This initial step lays the foundation for the secure storage and retrieval of passwords, helping us to develop a trustworthy password manager. In this part of our password manager, we're going to dive into how we encrypt and decrypt our entries using the cryptography library's Fernet symmetric encryption. At its core, this functionality is crucial for any secure password manager because it ensures that sensitive information remains protected, even if someone gains access to your data store. When we encrypt a password or any secret information, we're essentially converting it into a form that is unreadable to anyone who doesn't have the proper key to unlock it. This means that even if someone manages to intercept our data, they would see only a jumble of characters, not the actual passwords we're trying to keep safe. This process is vital because, in the real world, if a hacker breaches a database, we want them to hit a wall instead of scoring easy access to all of our users' credentials. On the flip side, decryption is just as important. When it's time to retrieve a password, we need a way to turn that unreadable string back into something usable. This is where the same encryption key comes into play. By using this key, we can reverse the encryption process safely and access the original password. It's worth noting that key management is a critical aspect of this process. You must keep your encryption keys secure and private, as anyone with access to the key can decrypt your sensitive information. By building these encryption and decryption functions carefully, we lay a solid foundation for protecting user data in our password manager, ensuring that peace of mind accompanies each stored entry. Quick breather, you're doing great, let's keep going. In this segment, we're going to create a simple command line interface, or CLI, that lets users add and retrieve their passwords securely. The idea here is to build an intuitive way for users to interact with our password manager without needing to dive deep into the code. When you think about a password manager, it's crucial not only to store passwords safely, but also to provide easy access to them when needed. So, we'll start by implementing an add functionality where the user can input a website, username, and password. This allows users to save their login information in a structured way, making it easy to recall later. We will also ensure that the passwords are encrypted with Fernet encryption before storage. This is vital because it protects sensitive data from being accessed by anyone else, even if they get hold of the file where passwords are stored. Next, on the retrieval side, we'll let users request their saved passwords by specifying the site name. This functionality will decrypt the password before displaying it, ensuring that sensitive information is only visible to authorized users. The whole process mirrors what we expect in today's digital world, where security and convenience must coexist. This CLI approach offers a lightweight solution that is accessible to many users, regardless of their technical background. By providing a straightforward means to manage their passwords, We empower users to enhance their security practices in a practical and approachable way. Still with me? Here comes the next piece. Now that we've set up our encryption with Fernet, let's dive into how we can store our encrypted password entries locally. The main goal here is to securely save the credentials so we can access them later, while making sure they can't be easily read by anyone who stumbles upon them. When we save data, we can't just dump it directly into a text file in plain sight. We want to keep it confidential. That's where our encryption comes into play. By using Fernet, we're essentially turning our sensitive data, like usernames and passwords, into a jumbled string of characters. This transformation ensures that if anyone gains access to the file, they won't be able to make sense of the stored information without the specific key we used for encryption. In practice, we can encode our entries and then store them in a simple format like JSON. This not only keeps our data comprehensible for our program when it runs, allowing us to retrieve and decrypt it later, but also leverages a format that is widely supported and easy to manipulate. We're thinking of potential future applications too, like adding new functionalities or expanding our manager's capabilities. When we save everything in a structured way, it opens up a world of possibilities for retrieval and management. Remember, the security of our password manager hinges on the integrity of this storage. If our key is kept secure and our entries properly encrypted, we're contributing to a safer digital experience, essential for personal data management in today's online world. Nice pace so far. On to the next step. As we wrap up our journey in building a password manager, let's recap what we've created together. We've established a secure method for storing passwords, using Fernet Encryption to ensure that your sensitive information remains safe from prying eyes. This means that even if someone accesses your storage, they won't be able to decipher your passwords without the proper key. We also implemented a user-friendly interface that simplifies adding, retrieving, and deleting passwords, making it accessible for anyone who might be concerned about their online security. In a world where data breaches are prevalent, having a reliable password manager not only helps you stay organized, but also significantly enhances your digital safety. Embracing these best practices puts you in control of your online identity, giving you peace of mind as you navigate the digital landscape. Thank you for joining me in this endeavor. Protecting your personal information is a vital skill in today's connected world.